Good morning. Happy Monday. Okay, and here we are on, where are we? March 1. Homework 4 is due tonight. Homework 4 and 5, one of them is requirements, one of them is UML diagram. So no coding. And let's see, I'm publishing a survey, hopefully today, to be due Wednesday, to check in on people and make sure people are feeling that they're able to participate in the course, that you have the resources available to you, and even though we're virtual, that you have some sense of that this is a real course. So look for that. I will make an announcement. I see the discords are pretty strongly, so that's good. And I got some email questions over the weekend about the lab 5, which was also good. Okay, so now finally we've been doing programming and nothing's been showing up on the screen other than in console. And now we get to actually have graphical widgets showing up on the screen. What we'll talk about this week is just basic presentation, not user interaction. They're two separate things. One is to just present information or objects or shapes to the user. And then the other one is actually getting user interaction through, text field input or clicking on buttons or keyboard presses, things like that. So we'll move into user interaction next week. But this is just about presentation. Okay, as always, review these at the end of the week. I hope you do that. So before we talk about the nuts and bolts of how to present things on a screen, let's talk about this thing called a model view controller pattern. A pattern is any group of classes that show up over and over and over again, and they show up with enough commonality, with enough frequency that people have said, look, if you've got to do this job, use this pattern. And the pattern here is called model view controller. The idea is there's 3 parts to your software. One is the model, that's the actual thing that you're dealing with. One is the view, that's the thing you see on the screen. And one is the controller, which is the interface between the screen, what's shown on the screen, the view, and the model. So you see something on the screen, and then you click a button, and then the controller registers that button click, and then tells the model to go change itself. And then the model gets changed, some attribute value gets changed, something happens, and then that result is shown on the screen. So it's this constant loop of looking at the screen, clicking on a button, or moving the mouse, or doing something, pressing a key on the keypad, which tells the controller to go tell the model to do something in response to that. The model does something in response to that, and then it gets updated on the view so the user can see that the thing they asked for actually happened. But they are 2 separate things, the model and the view. And I push this and push this and push this because it's when you're first encountering GUI related programming, that is not an obvious distinction, but it's a very helpful distinction. Now, in a sense, you already know this without knowing it, right? So let's make explicit what you already know. You guys all just finished doing this homework where you made projectiles fly. Did you show the projectiles on the screen? No. I think one person said, hey, I want to move ahead and do it on the screen too. Can I do that? Yeah, go ahead. No, you did not. So in other words, you have a projectile. It exists. That object exists. That's the model of the projectile. It exists in data form. Now, if you want to see the projectile flying across the screen, an animation of that, that's the view. And unfortunately, because we all grew up playing video games, we think the thing on the screen is the actual thing. And it is absolutely not. It is the presentation of the thing. It is the view of the thing. But the actual thing is a model in data somewhere in the guts of the computer. So when you're playing your online video game, like a race game, and you're racing around with the other cars and you see the other cars, they are not the other cars. That's the visual presentation of the other cars. What are the actual other cars? Well, somewhere there's a car class, and then there's a car object, and that car has a location and a speed and a direction and a driver quality and a whatever, whatever, whatever. All that data is the actual car. Now, you couldn't play a game by looking at the data. Unless you get like the Matrix, right? Where you can see the Matrix, right? That's what that would be like. You can't play a game by looking at the data. You play a game by looking at graphical representations of what the data represents. But because we've all been playing these games, because we all deal with the GUI interface so much, we have the mistaken belief that that's the actual thing. You know, when you're doing your Word document and you're changing the words on the screen, that thing you see on the screen is absolutely not the Word document. The Word document is a big bunch of data in the memory of your computer. So I want to push this and push this and push this, because while you're doing your projects, and I hear it in the language that people use when they're describing their project. Oh, I'm going to have a maze and you can't run through the wall of the maze. Okay, that's great. You're thinking visually, but until you figure out how to represent a maze in data form and make sure people can't go through the walls in data form as if you never saw it, right? As if you did it like a homework 3. Build a maze and have an agent go through the maze, not shown on the screen. Until you think that way, you're not going to be able to program anything of any complexity. So the question is always, when people start saying, oh, I want to do this on this project and that on that project, and my question is often, I love it, great idea. What's the data look like? How are you representing that in attributes? How are you representing that with numbers or strings or whatever? So I want to push this and push this and push this. And we'll see this as we get, again, as you go through your homeworks, you should be seeing this already, because again, you created a projectile, you've done it. In the later homeworks, you're gonna show those projectiles flying on the screen. But you know that the thing on the screen is not the projectile because you've already got it. You've already got it in homework 3. Students will have issues, some, with if you don't keep that distinction clear, it causes cloudiness in your thinking and issues with your project. So years ago, I had someone doing a pool game, having trouble getting the physics right with how the pool balls bounce off of each other. And the real problem was he was trying to attach those behaviors to the circle on the screen, did not have an underlying data model of what a pool table was. Once we fixed that, the person got some success. Okay, so are you sick of the sheepdog game yet? I thought it was such a good example because it's so simple, but it also shows, you're just sucking up to me, Milana, but I appreciate it. It's so simple, but it has everything we need to talk about in the course. So remember, these are not sheep you're looking at. These are not dogs. You guys know what a dog is. It's a class that has an X location, Y location, X speed, Y speed, and max speed, and a move method and a vocalize method. That's what a dog is. What you're seeing on the screen, this little gray circle, is not the dog. It's the representation of where the dog is at any point in time. And how are we going to make the sheepdog game work? Well, we have to introduce a controller at some point that says, hey, if the user clicks the up arrow, I'm designing my solution into the problem statement. If the user hits the up arrow, you should speed the dog up. If the user hits the left arrow, you should turn the dog to the left. That's the controller's job. And then that'll change the model, because it'll change the attributes of the dog, X speed and Y speed, and then it'll also be updated on the screen. The view will be updated by showing the dog turning or moving faster. And so if we look at our UML diagram again, the model is all that stuff under the hood. The view is all the GUI stuff. And the controller, because it is an interface between the two, will kind of bridge these things. There will be a little bit of, yeah, it's in the GUI, and a little bit of, okay, it's got its own class that doesn't show up in the GUI. So we can have a game controller that doesn't show up in the GUI, but at some point we have to tie that into the GUI. And what I tend to do, which I'll show you next week, is introduce panes that have the specialized panes, specialized basically windows in the GUI that have the behavior that I want. Okay, JavaFX. So we have to use JavaFX. Remember when Java first came out, they used AWT, Abstract Windows Toolkit. Nobody liked it. Then they went to Java Swing. Most people didn't like it. And so now they're at JavaFX. It's been around for a while now. It's been around since Java 8, and I think we're up to Java 11 now. And so far, it seems okay. I like it. I think it's a pretty good thing. They have a very loose correlation to theater here, and I'm not sure why they started this way, because they don't follow the analogy very strongly. But the top level entity they call the stage. See, there's your theater presence. And then inside each stage, you can put different scenes. So just like in a real theater, you can have one stage, but in between acts, the curtain comes down and the people come out and change the scenery, and you have a new scene. You can pop different scenes into your stage. And then inside of each scene, you can have a pane, or actually more than one panes. We'll talk about that. And a pane, think like a window pane. It's what you see through. So the pane is what you see inside the scene. And then the same trick applies. You can pop panes in and out. And so you can, when you want to go to a different page, I've got a game with a welcome page, click on start game, and now the game page comes up. You can do that by just swapping out panes inside the scene, which we'll show. That's a really easy thing to do. And then inside of the pane, anything inside the pane, we're going to call a node. And that comes from graph theory, but we're going to call that a node. So buttons, text boxes, images, other panes, you can put them inside the other. All of those are nodes. So that's just the terminology. And what you've got is this Russian nesting doll format. You've got a stage, a scene, a pane, a nodes. So let's say you wanted to put a button into a pane. You build the button, you put it in the pane, you put the pane in the scene, you put the scene in the stage. And we're going to do that over and over and over again. You build the buttons, you put the buttons in the pane, you put the panes in the scene, you pane in the scene, and you put the scene in the stage. So be aware that I will say that a lot over the next 2 weeks. So what kind of nodes are there? Well, a pane can be used as a node, because it turns out you can put panes inside of panes, and we're going to take advantage of that. And you've seen this also before. Even on the screen that you're looking at right now, you see the big slide in the middle, and you see on the left my slide sorter, right? My series of slides. Those are in 2 separate panes. So it's a way to divide up the screen. And if I wanted to take a figure here, let's see, can I do this? Format shape. Look at that, another pane pops up. I shouldn't have done it. It's going to take forever to get rid of it. There we go. Okay, so you're aware of the concept of panes, multiple panes within a window, and this is how you do it. You can have a large overarching frame and put multiple panes inside, and we'll talk in detail about how to do that. Java actually gives you several kinds of panes, some of which are really nice to put other panes inside. And then the things you would expect, text labels, text fields, which you can type into, and then the machine can get the data from the text field. Buttons, so you can click on things to make them happen. Images, menu items, drop-down boxes, radio buttons, check buttons, anything that if you guys have been, if any of you have built interactive HTML pages, you know you're familiar with all the widgets. If you like tabbed applications, there are pre-built Java tabs for you. So this is one of the places, by the way, where the object-oriented paradigm really helps you, because they give you all these things as objects already built. They already have a lot of behaviors associated with them. You don't have to design from the ground up. And so you're able to create your graphics items pretty quickly. So here's an example. The stage is the entire window, and that entire window, you know, in Windows, a window always shows up with the on the upper right-hand corner, the underscore line, the square box, and the X, right? So you're going to get that for free. The Java stage class provides that. And then you get a title on the right-hand side of the window bar on the top. There's always a title to the window. That's the stage. And then inside the stage is a scene, which you never see because this, you know, the scene is containing, all it does is contain the pane. And then inside the scene is the pane. And then inside the pane are the nodes. And in this case, these nodes, it's R1, R2, R3. Those are text labels. Those are labels. And then you see three different rectangles, the white one, the black one, and the one with the curved edges. And then you see those four rectangles overlaid on top of each other, rotated. All those rectangles are pre-built graphic images that Java gives you, and they are the nodes inside the pane. So you have an interesting challenge. You know, let's go to the maze game. You're going to have a maze built in data, and now you have to convert that data to, oh wait, what does that look like on the screen? You know, quite a few people, they like to do platformer games. They're very popular now. And my question is always, okay, how does that platform look in data? What does a platform class look like? And then once you have the platforms built and positioned in data, how do you translate that to the screen? You know, and it's probably pretty straightforward, like just make a line, right? That's probably a pretty good answer. But you have to think through that stuff. Now, because we're using stage and scene and pane and different nodes, and these are all pre-built Java objects, classes, I should say, we have to import them, right? We have to bring them in to the program, just like the scanner. You had to import the scanner. So you're going to do a lot of import statements at the beginning of these files that have GUI stuff. So for example, the first thing you do is you bring in something called application. That's just what they named the top level GUI object. And so if you look at this simple hello world example, you bring in application, you bring in scene, you bring in a button, you bring in stage, and that's because for hello world, you know, we need the stage, we need the scene, and then we put a node inside the scene, which is the button. And notice the pane is missing, and we're going to show that that's a bad thing. With that top level thing is application, and your top level GUI class always extends application. It's required. This is why in your project I say you must have inheritance in your project, but it cannot be GUI related. And the reason is all of the GUI classes are extensions of application. So that would be a non-useful way in terms of, you know, course learning outcomes to use inheritance inside of your project. And instead of main, we use start. So application is kind of a funny animal, and I'll remind you of its oddness from time to time. But the first most fundamental, most visible change is instead of having a main method, you have a start method. Now, again, when we started out with main and I said, let's use main, you know, why do we do that? Well, the answer is that's just how it is, right? That's just how Java was built. And now it's the same answer. Why start? Well, that's just how it was built. And then what you do, because remember, application came to you. Didn't realize that volume was up, sorry. Application came to you as a pre-built object, and you're extending it. What does that mean? It means application already has a start method in it. It's an empty start method. It doesn't do anything. And then your job is to fill it in, which again matches exactly what inheritance is all about, right? You extend the parent and then you modify the methods. So in order to write a GUI application program, you're going to start with the application, extend it, overwrite the start method. Think of it as the main method. So basic process. This is how the process that I've settled on. I make all my nodes. I make a pane. There's not one in this example, unfortunately. I add the nodes to the pane, and then I add the pane to the scene, and then I add the scene to the stage, and then I show the stage. So if you look at here, it says these lines 26, 27, 28. 26 says primary stage set scene, and how big is the scene? Well, when you created the scene, you said it was going to be 400 by 500. So that's X and Y dimensions in terms of pixels. And then you say, so you build the scene, then you say primary stage set scene scene. Well, guess what the method set scene does? It plops a scene into the stage. And then primary stage set title, you don't have to do that. And then primary stage dot show. That's then what you do is you're building all this stuff up. And when you do primary stage dot show, it pushes it out to the screen so it's visible to the user. So I say this, I'm recommending this process that you make your nodes, make a pane, add the nodes to the pane, make a scene, add the panes to the scene, and then add the scene to the stage and then show. And if you follow that process, then, there's a little more clarity. As always, you're trying to take a big problem and put it into smaller problems, right? So there's a little more clarity on what problem am I trying to solve right now? Oh yeah, I'm trying to make all my nodes. Okay, now I'm trying to put them in the pane. This is a slightly more sophisticated example because it has a pane. So there you see it, import JavaFX scene.layout.pane. We're extending application again. We're using start instead of main. And then the basic process here, it's the same one, but now it's a button, but now it's a button inside of a pane. And I'm going to run this code in a few minutes, and we'll see why the pane is really a good thing to have. Same trick, right? I make a button, I make a pane, and then I add the button to the pane on line 27. And then on 29, I make a scene. And notice you're adding the pane to the scene while you create it. And then on line 31, I put the scene in the stage. And on line 33, I show. So I'm going to walk through. I want to talk about a couple of things here. I named my button BTOK. I name all my buttons BT for button. And then the name is hopefully something that is useful. It tells you what the button does. Now here the button doesn't do a damn thing. So, it doesn't matter too much what we call it. I'm calling it BTOK. And if I have a text field, you're going to see I name them TF and then the thing that the text field is, that kind of naming convention. And then on line 26, we say pane equals new pane. I hate that formulation, but it's so common. We're going to do this a lot. Circle equals new circle. Pane equals new pane. Scene equals new scene. I don't like naming the thing the class. That's just me. But you get used to that after a while. Obviously, if you have 2 or more panes, you can't get away with that trick. And then we add the button to the pane, but look at that weird formulation on line 27. Pane.getChildren.add, and then you put BTOK in there. So in order to add things to the pane, you use the add method. Then to build the new scene, whenever you build a new scene, you have to say what you're putting in it. So we say we build a new scene, and then I put the pane in there, and then I say what size I want, 400 by 500, whatever it is. then set the scene in the stage, and then show. I'm going to work, I have this as example code, and I'm going to show it to you. Notice I've named them FX01, FX02. That's because that way I remember what sequence to show them off when we do the code. I've told you when you had main to try to keep your main method clean. Don't do a lot of work inside of main. Instead, just do a bunch of method calls and do all the real work in the method calls. And here's an example of how that works. If you look on the left, we're creating those rectangles that you saw in that previous picture. That code on the left produces this picture. And the start stage starts up, it's an image, so I can't, it starts up here and goes down here. So we're looking at like, I don't know, 20 lines of code, 25 lines of code. And I promise you, when you start to make sophisticated GUIs, your start method gets all cluttered up with just stupid, boring, make a rectangle, put it here, make a text field, put it here, make some actual text, format it this way, put it here. And man, if you really just want to find out what the heck is this program doing, that's a lot of garbage to wade through. So instead, I'm recommending that you do what I did on the right. If you look at lines 30, 31, and 32, those all go to individual methods that have all the detail in it. So, you know, the line 30, make rectangles, that's going to make rectangle 1, rectangle 2, rectangle 3, and my a rectangle array. I'm sorry, rectangle 1, 2, and 3. And then the next line, which says make rectangle array, is going to make the rectangle array. And notice in order to do that, I had to actually create on lines 24 through 26, I had to make these things as attributes. So on the left, these rectangles and panes and things are not attributes. They're variables inside of the start method. And on the right, they're attributes. And I promise you, you really want to make your things attributes. You want them to be persistent. You want to build other methods that have access to them. But look at on the right, man, if you wanted to know what the heck is going on in the code, well, make rectangles. Gosh, I can pretty well guess what that method does. And if I need to know the details, I'll go look at it. And then make rectangle array 3, I have a pretty good guess as to what that does. And then pane equals make pane with rectangles. Oh, I have a pretty good idea what that does. If you name your methods what they do, then your code is readable, right? This goes back to the commenting question. How much commenting should I put in code? Well, if I put off to the right, you know, make rectangles is the method name, and off to the right, I put / makes the rectangles. Doesn't add much information. So if you name it well, then you don't need a lot of commenting, and your code is pretty clean. So now my start method is only 6, 7 lines big. All of the detail is in the other methods. Not a bad way to write your code all the time. Make methods that do little tiny things with good names, and then when you write your code, it's a bunch of method calls. Ultimately, your code is maybe a little bit longer, but at each individual point, there's much more clarity as to what's happening. Yeah, so primary stage, if you look, it says oh, let me bring this up. So now I can play around with this stuff. So here's a hello world application. And if you look, it says public void start primary stage, and primary stage is actually, remember stage, JavaFX stage, right, was imported. So that stage is created and it's handed to the application class as basically the handle to the primary stage is input into the start method in the application class. Right, so you can treat it like you don't have to build one because you're building it as an input to the method. Now, Can you have more than one stage? In other words, multiple windows open at the same time? Yes. And if you do that, then you're going to want to have your own attributes, you know, stage number 2, stage number 3, stage number 4, or whatever their job is, help screen stage, things like that. And then you have to actually say help screen stage equals new stage to build it, right, to build an object of that. But your primary stage, your first stage, you do not need to do. And by the way, the name primary stage could have been anything, but primary stage is probably a really good name, because what is it? It's the primary stage. Okay, so here's the thing we just looked at. Now, this is basically straight from the Liang text, right? I took all your code, and I think I gave you both versions. The Liang text, you know, when you look inside, you're going to see basically these exact same pieces of code. But I had great issues with how the Liang text wrote the code. I thought they wrote lousy code, and I don't think we should show students lousy code and use that as a class example. So I built what I hope is less lousy. And if you can look and compare and see what's different. I believe if you build a button, you should always name the button. And Liang text wasn't doing things like that. They were building things with no names and building them inside of other method calls and in interesting things that are cute Java tricks, but not helpful to a first-time student. So I tried to have a uniform process here. Build the node, build a pane, put the node in the pane, put the pane in the scene, put the scene in the stage, show. Okay, so the start method goes, again, this is super simple, right? Button, and then we add the button directly to the scene without a pane, and the scene is 400 by 500. We put the scene in the stage, and then we show it. And let me see here. Okay. Hopefully it's already compiled. And there it is. It's 400 pixels across, 500 pixels deep. And it says, okay, and if you look, I'm clicking the button. You can see that I'm clicking the button, right? Because you can see that color flashing. So that's a button. It's a button that filled up the whole scene. And, you know, obviously this is not helpful. Also, when I click the button, literally nothing happens. And the reason is we never told the button to do any actions, right? We don't have a controller yet, so we don't have any way for the buttons to do anything. It shows up. I can click it, it's functional, but I haven't tied an action to it yet. And next week, we're going to tie the action to the buttons. So let me run the second one. That's FX02. Zoom always has its stuff in that way. Show button, okay. Okay, now what do we have? Now we have a button in a pane, and again, we can click it. It's a functional button. It just doesn't do anything because we haven't tied the action to it yet, but it's in a pane, and look at, now it's a normal looking button. That's why you put all your nodes inside of panes and then put the pane in the scene. If we look at the code for that, not very complicated. We have to add the pane, right? So here we are on line 17, importing the pane. And the same trick, on line 24, I make my button. And then on line 26, I make a pane. On line 27, I add the button to the pane using the dot add. If you have a bunch to add, by the way, and I think I have a demo of this, there's an add all, and you just put them all in one after the other separated by commas. But if you just need to add one thing, it's the add method. And then I build a scene, and notice I'm putting the pane in the scene. And then I put the scene in the stage and show. And now that the button's in a pane, it's going to have a better behavior. And its better behavior is it has a normal size. It doesn't take up the whole thing. How do you think the size of the button was determined? The button text, right. Save. Whoops. The button text. What if you want to fix the size of the button? What if the button text is small, but you want a great big long button, or a big long and tall button? Can you do it? Absolutely. The answer to all these can I do it questions, by the way, is yes. How do I do it? I have no idea. That's what you have to go look at the Oracle documents for, right? The Oracle, they're the people that own Java. They've got terrific help pages for all of these things. Now, what about the button position? Notice it's in the upper left-hand corner. Why? 0, 0, right. Wait a minute. 0, 0, why isn't 0, 0 on the lower left-hand corner like it is in algebra? So here's how GUI systems work. 0, 0 is in the upper left-hand corner. Why would you put 0, 0 in the upper left-hand corner? Because watch. Look at that. When I move the screen around, what stays still? Upper left-hand corner. Upper left-hand corner stays still, so that's the origin. And positive X goes from left to right, as you would expect. Positive Y goes down. So this is going to have some interesting things, right? So I have students sometimes who are saying, hey, I'm moving my widget, and I want it to go from the top of the screen to the bottom of the screen. So, thinking in algebra terms, I made it move in a negative Y direction. And guess what? They're actually making it shoot off the top of the screen where it can't be seen. So 0, 0 is in the upper left-hand corner. I should put that on a slide, shouldn't I? 0, 0 is in the upper left-hand corner. Positive X goes to from left to right. Yeah, as you would expect in algebra, and then positive Y goes from top down. So you take your first quadrant of algebra and flip it down, and that's the only thing is the Y. What we think of as negative Y in algebra is positive Y in the GUI systems. Which means, by the way, you're going to have some interesting things to think about when you do your projectile motion in the GUI, because you're treating Y with 0, 0 in the lower left, and you have to present it with 0, 0 in the upper left. So there's a little bit of a math conversion there. Okay, so that's why it's up there. Since I did not specify a position, it defaults up there to the upper left-hand corner. Could I specify an XY location if I wanted to? Absolutely. And how do I do it? I can't remember right now. I think it's set X. It might be set X location. And so, yes, you can. And you can do a whole bunch of weird tricks, like put it center on the screen, and as the screen changes size, it always stays in the center. You can do stuff like that. And we'll talk about some of that as we go through. But when I show you the actual classes for these buttons, you'll see that I can't show you all the methods because there's hundreds of them. most of which have to do with either formatting and positioning or setting actions. So yes, you can do all kinds of things. Could your button be? Yeah. So I would imagine all graphical systems do that. Yeah, that's why. Because it's the thing that doesn't move when the screen changes. Okay, I better recompile before I forget. Okay. And I better verify that I recompiled. Okay. Okay, so now we've gotten a button in a pane. And again, it doesn't do anything. It's just sitting there being a button. So if we look at this one, there it is, lines 24 and 25, BT set layout X, BT OK set layout Y. Again, this is another reason why you want to name your nodes. Again, so you have access to them, so that you can do stuff with them, like put them where you want. And again, if you're going to do an animation, you definitely want to be able to name that thing. So if you have a circle that represents the projectile in your projectile homework, remember the circle is not the projectile, but it represents the projectile on the screen. You want that circle to be an attribute so that you can keep doing set layout X, set layout Y, or set center X, set center Y, whatever it is for a circle. So here's a button that we modify slightly. I think all I did is change its location. And we're able to put it in a fixed position. And notice it is a fixed position. Ah, shoot, lost my button. Okay. There are so many things you can do with these allegedly simple graphical items. Okay, but again, notice the pattern. I make the button, then I mess around with the button. I make the pane, I put the button in the pane, put the pane in the scene, and put the scene in the stage, and then show. Now notice I'm doing everything in start here. This is about my limit. If I had 2 buttons, I would probably shove them out into a method. Okay, now let's do the simplest graphical object we can, a circle. And again, this is from the, yeah, notice that circle line 24 through 29 is creating the circle. So we do a couple things. We have to bring in circle as an object. That's not surprising. So now we're going to bring in application, scene, pane, stage, and circle. And you can imagine if you have buttons and text fields and images, you know, that import list starts to get pretty long. That's okay. Oh, and we have to bring in color too. That's weird. Talk about that in a minute. Let's see, do I want to get through? That's probably all. This might be the last one we do today, and then we'll get to, because I want to show you the Oracle help pages, and then we can get to the rest of these on Wednesday. So this week is primarily about just showing you code, showing you code, showing you code. I've given this code to you. So please run it yourself, play with it. Oh, and of course, Eclipse has a weird trick that you have to do to get JavaFX to work. The FX libraries are not automatically accessed by Eclipse. So you have to go to your, again, you can go online and find this, and there's also instructions in the labs, I believe. You know, you have to go to your library section inside of Eclipse and add the FX library. So just be aware that that may happen. You notice I do everything outside of Eclipse, and that's because I don't want to put up with that kind of BS. So these are too simple to require Eclipse. Okay, anyway, look at how we do a circle. Circle, circle equals new circle, no surprise there. And then we set center X, set center Y, so we're able to position it. We set the radius. Oh, that's about all you need. That's about all you need for a circle. And if you don't do anything, it's going to be just a black, I think it's just a black outer outline with nothing inside. And then I do this, circle set stroke. What is that? That's setting the line. And it's color dot blue. Color is an object in JavaFX. And there are a number of predefined values, blue. By the way, it's color.blue. Now, since it says .blue, is that a method call or an attribute? It's an attribute because there's no parentheses. What does it mean that blue is spelled in all caps? It's a constant attribute, right? That's what it means. So that color.blue, you're referring to a fixed value, which hopefully will look like blue. And then inside here, circle.setFill, null. Oh, we're used to null by now, I hope. If you don't want a color value at all, if you want the thing to be transparent, it's null. Okay, so then we show this thing and whoops, I'm gonna turn you off and I'm doing, which is this FX04 is show circle, okay. Ta-da, there's a circle. Now notice it's partly off the screen because I didn't position it far enough over. But it's blue. And you know, what if you wanted a thick line? Yeah, you can set the thickness. Okay, so let's see. If I go to what? So here's the circle class. And by the way, it tells you its history. The circle is a child of the shape class. The shape class is a child of the node class. The node class is a child of the object class. Everything you create is always a child of the object class. And then they give you some examples, right? So they give you some nice, yeah, I think I followed their example. And then they give you some basic properties, which we're not going to talk about too much here. You can tie properties to other properties of objects. And the Liang text has an example where they tie a circle to the width of the window. So as you change the window, the circle size keeps changing. And then we have, oh man, look at all this stuff. Properties inherited from JavaFX scene known. Look at all this stuff. On mouse drag release, on mouse entered, on mouse exited, on mouse moved. In other words, they're setting up all kinds of things you might be able to do. If you move your mouse, you know, you've seen this before, right? You move your mouse over an image and it switches to a different image. Oh, you can do that. You can have it where when your mouse enters the circle changes color. When the mouse leaves the circle changes color. When someone clicks down on the mouse key, something happens. When they release the mouse key, something happens. This on swipe left, on swipe right, that's for use on phones. And then we have fields, constructors, right? These are nice little summaries, properties, blah, blah, blah. And no, look at all this. Here's all the methods. Here's all the methods that thing has. You thought a circle was simple. Of all these methods, you're pretty much just going to use a couple. Set layout X, set layout Y, set stroke, set fill. That kind of thing. Oh, I gotta let you go, but I'm going to show you color first. Color blue, that's awfully restrictive. Is the user, absolutely. The user's mouse location is always available, right? So the thing with the color is you can do them as you would expect with red, blue, green, or hue, saturation, whatever the other one is. And you can also do them with the constants. The constants are not restrictive. You know, in a lot of like PowerPoint, they give you like 9 different values for color. But look at these. These are all the different colors that exist. You know, if you can't find a color you like here, you know, you can always make up your own using like RGB values. There's a million different colors. All right, guys, I gotta let you go. Thanks for being here. And I will see you on Wednesday.